7.7 is base E and natural logarithms, okay? And so we need to have an understanding of what the number E is, and this can be found on page 1144 in your book. If you want to screenshot it, if you want to take a picture of this page, that's fine too. Or you can, take regular notes. It's up to you, and once you get that all in there and situated, I will talk to you about what this all means.
Wait, what page?
So, think about E like it is pi, okay? Pi is this sort of mysterious number that we always use when it comes to circles. E is a sort of mysterious number that we use when we talk about logarithms. And there will be some applications of it that we will look at in 7.8. But for the most part, what you need to know is that E is this number 2.71828, and it just keeps going. It is irrational. It cannot be expressed as a fraction. Okay, but it's a special number as related to logarithms. And it's called the natural base. All right. When we have an exponential function, when the base is E, it's called a natural base exponential function. Okay, so this is a whole nother area of math that is unique. And we will look at some applications, like I said, in 7.8. But 7.7 is all about mechanics and figuring out how to use base E and what the natural logarithm actually is, and we kind of go from there. Okay, so the best way to get into it is actually just to talk about how I could rewrite these in logarithmic form. Okay, so both of these have base E. These are exponential equations with base E. And anytime we talk about an equation in base E, we're talking about a logarithm with base E, and that actually is the natural logarithm. So go ahead, just like we did before, rewrite these two equations. Actually, just do the first one. Do the first one. Rewrite that in logarithmic form. Don't do B yet. Just do A. Write that in logarithmic form. Now, that one should have been pretty straightforward because we've done this before, right? So log base E of 8 equals X. How many had that? Okay. Now, here's the trick to all of this. We don't ever actually write log base E. That actually has a different notation that we use, and it's on your calculator. That LN button on your calculator stands for natural logarithm. Why it's LN instead of NL, I'm sure it has something to do with Latin or Greek or something. I don't know. Logarithm natural. I don't know what it is. So what we do, instead of writing log base E, we change that to the natural log without a base, because the natural log, that ln, means log base E. And just like when we looked at the common logarithm, when we wrote the word log without a base, and we understood that that meant log base 10, when you see this notation, ln, that means natural logarithm, which means log base E. Now, I will tell you that some of you will want to write this and then go to this, which for now is fine. Eventually, I want you to make the move to jumping from here to here without writing this line. And after you practice it a few times today, I think you'll probably have a good understanding of how to do that. Now, that being said, go ahead and do B, rewriting this in logarithmic form. Understanding since there's a base E, there's going to be a natural log in your answer. So, this really would be log base E of x equals 5. And so, since that is the natural log, which is log base E, that's what you should get for your answer. How many had that? Okay, so that's good. So in reality, there's nothing new here other than notation. Going from exponential form to logarithmic form, or logarithmic form to exponential form, those mechanics are the same as what we've done previously. We have a new notation. Whenever I have a base of E, we use natural log. But the reality is nothing is, besides the notation, is new. And the number E, of course, is new. Okay. Let's look at another couple examples. So let's go the other way now. Okay, so here are two equations in logarithmic form. Go ahead and write those in exponential form. So give that a shot. You can do both of those this time. Again, this concept is not new. The fact that there's a natural log instead, that's the new part. Let's take a look here. So this is base e, so e to this power. Remember, logarithms are always equal to powers. Natural logarithms are also equal to powers. It just happens to be that the base for this power will be e. So on the left, what you should have had is e to the 0.7741 equals x. How many had that? Okay, so again, it's the same idea. We're just going to loop around this way, okay, in the base here, right? So this is going to be e to the equals 10. How many had that one? Okay, that's literally half of your assignment. Third. Going from logarithmic form to exponential form, or exponential form to logarithmic form. Again, more practice at that, but with base e and natural logarithms. All right, next piece. The next piece has to do with our properties. Our properties that we worked on previously. When I'm going to combine this into one log, we have to use the properties that we learned in order to make that happen. Okay? Even though it's natural log instead of log, the properties all work the same. Question?
Do you have to put it in the, like, when you're doing this, is it easier when you put it in a log e again?
If you want to do that, you can. Just got to make sure to switch it back. But eventually, I want you to get to a place where you're not doing that. Okay. What's my first move going to be here? Put the 3 as an exponent. Okay. That's going to be my first move. So that becomes natural log of 10 to the third minus natural log of 8. So I took care of the power. Okay. Now I got to figure out a way to bring these together. Divide because it is subtraction. So when I bring them together, I bring it together as one fraction. Natural log of 10 to the third divided by 8.
How do you know which one goes on top and which one goes on top?
The one that comes first goes on top. The one that follows the subtraction sign goes on the bottom.
Okay, makes sense.
Okay?
That's not how it was the other thing. It's complete opposite.
If I was... No, it wasn't.
The other one?
Alright. Now, what is 10 to the third? What is 10 to the third? 1,000. What is 1,000 divided by 8?
I don't have my calculator here with this.
125.
125. So I can simplify this down, okay? And so now I've rewritten this expression as one single logarithm using my properties. So again, nothing really new here. These are properties we've already gone over and covered. It just so happens they're in the frame of natural logs instead of just logarithms, okay?
You put this one?
Next problem, okay? Now, hopefully you're starting to figure out the first thing that you have to take care of before you combine them together is the power. Which one of these is going to have to become a power?
Oh, the 2.
The 2. This 2 is going to have to slide in and become a power. And once you've done that, and you've got all the numbers out in front from the logs gone, then you can bring them together using your either multiple product property or your quotient property, okay? So my first move is to bring that 2 into the 1/2 as a power, okay? And so what is that? What's 1/2 to the second power? No,
it's 1/4.
1/4, okay? So then what am I going to do with 40, 1/4, and x? Multiply because it's addition. So in reality, what I'm going to do to bring them together is multiply those three things. And so what is all of that? 40 times 1/4 times x. 10x, okay? Natural log 10x, that's my answer.
Seems simple.
So let's revisit what we've done so far. Okay? It's really review. Go from exponential form to logarithmic form, from logarithmic form to exponential form. Combine our terms using the properties that we learned in 7.5. So all that is really review. The last thing that we have to do, that we haven't done yet, is solve equations. Okay? And so we're going to have equations like this, exponential equations with base e. So all these exponential equations that we've done before, the only thing that's going to be different now is the base is going to be e instead of some number. Alright? And in order to solve these equations, we have to use the same strategy that we used before. And in this case, what we're going to do is get the e term by itself. And once that e term is by itself, I will tell you what you need to do. So go ahead and rearrange that equation so that the only thing on the left-hand side is e to the negative 2x. Get everything else to the other side. So go ahead and do that. Let's take a look. So my first move is going to be to add 5 to both sides. And then my next move is to...
But e's not by itself, but they're negative 2x.
Doesn't say...
Divide by 4.
Divide by 4. Okay. Now, so again, what it says is get the e term by itself. And the e term has a power of negative 2x, which is okay. But let's think about this. We're trying to solve for x. It's an equation, that's the variable. I know you look at e and you think of it like it's a variable, but e is a number. And on the very first slide, we talked about e and what that number is. Okay? We did. So my variable is in the power. And in the past, when we had to get that variable out of the power to solve that equation, what did we do?
We put it to the side.
But how did we do that? We couldn't just put it in front.
No, we have to make it a log.
Yeah, so we would take the log of both sides. Okay? Now in this case, because the base is e, we're not going to just take the log of both sides. We're going to take the natural log of both sides. So the only difference here, compared to what we've already done when we solved logarithmic equations or exponential equations, is instead of taking just the log of both sides, we take the natural log of both sides because the base is e. Okay? And I'm going to flip on to the next slide where I've done that. So here's what that looks like. Literally, I've just put the natural log next to both parts. Okay?
Why wouldn't you do like ln2 equals negative 2x? Like you did on the first
Putting it into just logarithmic form, you could. But I want you to get used to taking log of both sides, because when we get to more complicated equations, doing that, putting it just into exponential form or logarithmic form isn't going to work. Now, let's understand what this really means. When I'm taking the natural log of an e to a power, the first thing that happens is that negative 2x drops in front using our power property. And then I want to talk about more specifically what the natural log of e is. Okay? Because in reality, and I'm going to write this to, I'm going to circle that real quick and show you. And I'm going to write it over to the side. Because of what we've talked about before, and this is really log base e of e, right? That's what this is. And if you remember at 7.5, when the base and the number were the same, this always equaled what? 1. Okay, e to the first equals e. Whenever you have a situation like this, natural log of e, that equals 1. And if you wanted to, you could type that in your calculator and check it out. So if you hit the natural log button, and then the e is probably right above the natural log button.
Oh, it's second.
It probably says e to the x, and so if you have to put a 1 in there, put a 1 in there. But if then you hit enter, it's going to give you 1.
Where is it?
It's the natural log button, and then it's right probably above.
Oh, that's crazy.
Oh,
Okay.
it's there. I see it.
Okay, so now the point here is, okay, taking the natural log of both sides essentially eliminates the e. And so I'm just left with negative 2x equals the natural log of 2. So I'm one move away from being able to come up with my answer. What do I have to do now?
Take the natural log of 2.
No.
Divide by 2.
Divide by
-2.
negative 2. So if I divide both sides by negative 2, I will have the x by itself. And this natural log of 2 divided by negative 2 is something you're going to type into your calculator and get your answer. So go ahead and do that.
Keep on closing parentheses.
Make sure, again, you close the parentheses on the natural log.
Parenthetical close.
So we end up with negative 3.466. Now, I want to go back because both Fred and Xavier asked me the same kind of question. Why didn't we just write this problem in logarithmic form to begin with? Why didn't we just go from the original problem to this? Okay? And the truth is you could do that. But one of the situations that I want you to be careful of is eventually we're going to start seeing equations where there's e's on both sides and we can't really combine them together. And so taking the natural log of both sides will be my only option. And so I want to prepare you for that so that when you meet those types of problems, you're going to know how to do them. Because oftentimes there is going to be more than one e term and it's just not going to work out. So if you recognize that you can go from exponential form to logarithmic form and be good, I'm okay with you doing that because obviously we end up there anyway. All right? But be careful. Don't forget that the strategy of taking the log of both sides or the natural log of both sides is something that's going to be beneficial down the road. Okay?